So in this video, we're going to talk about what Ingress is and how you should use it, and also what are different use cases for Ingress. So first of all, let's imagine a simple Kubernetes cluster where we have a pod of my application and its corresponding service, my app service. So the first thing you need for a UI application is to be accessible through browser, right? So for external requests to be able to reach your application. So one way to do that, an easy way, is through an external service where basically you can access the application using HTTP protocol, the IP address of the node and the port. However, this is good for test cases and if you want to try something very fast, but this is not what the final product should look like. The final product should be like this. So you have a domain name for application and you want a secure connection using HTTPS. So the way to do that is using Kubernetes component called Ingress. So you'll have a my app Ingress, and instead of external service, you would instead have an internal service. So you would not open your application through the IP address and the port. And now if the request comes from the browser, it's going to first reach the Ingress, and Ingress then will redirect it to the internal service, and then it will eventually end up with the pod. So now let's actually take a look and see how external service configuration looks like so that you have a practical understanding. So you have the service, which is of type load balancer. This means we are opening it to public by assigning an external IP address to the service. And this is the port number that user can access the application at. So basically the IP address, the external IP address, and the port number that you specify here. Now with Ingress, of course, it looks differently. So let's go through the syntax of Ingress. Basically, you have a kind Ingress instead of a service. And in the specification where the whole configuration happens, you have so-called rules or routing rules. And this basically defines that your domain address or all the requests to that host must be forwarded to an internal service. So this is the host that user will enter in the browser, and in Ingress you just define a mapping. So what happens when that request to that host gets issued, you redirect it internally to a service. The path here basically means the URL path. So everything after the domain name, so / whatever path comes after that, you can define those rules here. And we'll see some different examples of the path configuration later. And as you see here in this configuration, we have a HTTP protocol. So later in this video, I'm going to show you how to configure HTTPS connection using Ingress component. So right now in the specification, we don't have anything configured for the secure connection. It's just HTTP. And one thing to note here is that this HTTP attribute here does not correspond to this one here. This is a protocol that the incoming request gets forwarded to the internal service. So this is actually the second step, and not to confuse it with this one. And now let's see how the internal service to that Ingress will look like. So basically backend is the target where the request, the incoming request, will be redirected, and the service name should correspond to the internal service name like this, and the port should be the internal service port. And as you see here, the only difference between the external and internal services is that here in internal service, I don't have the third port, which is the node port starting from 30,000. We now have that attribute here. And the type is a default type, not a load balancer, but internal service type, which is cluster IP. So this should be a valid domain address. So you can't just write anything here. It has to be, first of all, valid. And you should map that domain name to IP address of the node that represents an entry point to your Kubernetes cluster. So for example, if you decide that one of the nodes inside the Kubernetes cluster is going to be the entry point, then you should map this to the IP address of that node. Or, and we will see that later, if you configure a server outside of the Kubernetes cluster that will become the entry point to your Kubernetes cluster, then you should map this host name to the IP address of that server. So now that we saw what Kubernetes Ingress components looks like, let's see how to actually configure Ingress in the cluster. So remember this diagram I showed you at the beginning? So basically you have a pod, service, and corresponding ingress. Now, if you create that ingress component alone, that won't be enough for ingress routing rules to work. What you need in addition is an implementation for ingress. And that implementation is called Ingress Controller. So the step one will be to install an ingress controller, which is basically another pod or another set of pods that run on your node in your Kubernetes cluster and does evaluation and processing of ingress rules. So the YAML file that I showed you with the ingress component is basically this part right here, and this has to be additionally installed in Kubernetes cluster. So what is Ingress Controller exactly? The function of Ingress Controller is to evaluate all the rules that you have defined in your cluster, and this way to manage all the redirections. So basically, this will be the entry point in the cluster for all the requests to that domain or subdomain rules that you've configured. And this will evaluate all the rules because you may have 50 rules or 50 ingress components created in your cluster. It will evaluate all the rules and decide based on that which forwarding rule applies for that specific request. So in order to install this implementation of Ingress in your cluster, you have to decide which one of many different third-party implementations you want to choose from. I'll put a link of the whole list in the description where you see different kinds of Ingress controllers you can choose from. There is one from Kubernetes itself, which is Kubernetes Nginx Ingress Controller, but there are others as well. So once you install Ingress Controller in your cluster, you're good to go, create Ingress roles, and the whole configuration is going to work. So now that I've shown you how Ingress can be used in a Kubernetes cluster, there is one thing that I think is important to understand in terms of setting up the whole cluster to be able to receive external requests. Now, first of all, you have to consider the environment where your Kubernetes cluster is running. If you're using some cloud service provider, like Amazon Web Services, Google Cloud, Linode, there are a couple more that have out-of-the-box Kubernetes solutions, or they have their own virtualized load balancers, etc., your cluster configuration would look something like this. So you would have a cloud load balancer that is specifically implemented by that cloud provider. And external requests coming from the browser will first hit the load balancer, and that load balancer then will redirect the requests to Ingress Controller. Now, this is not the only way to do it. Even in cloud environment, you can do it in a couple of different ways, but this is one of the most common strategies. An advantage of using cloud provider for that is that you don't have to implement a load balancer yourself. So with minimal effort, probably on most cloud providers, you will have the load balancer up and running and ready to receive those requests and forward those requests then to your Kubernetes cluster. So very easy setup. Now, if you're deploying your Kubernetes cluster on a bare metal environment, then you would have to do that part yourself. So basically, you would have to configure some kind of entry point to your Kubernetes cluster yourself. And there's a whole list of different ways to do that. But generally speaking, either inside of a cluster or outside as a separate server. And one of those types is an external proxy server, which can be a software or hardware solution that will take a role of that load balancer and entry point to your cluster. So basically what this would mean is that you will have a separate server and you would give this a public IP address and you would open the ports in order for the requests to be accepted. And this proxy server then will act as an entry point to your cluster. So this will be the only one accessible externally. So none of the servers in your Kubernetes cluster will have publicly accessible IP address, which is obviously a very good security practice. So all the requests will enter the proxy server, and that will then redirect the request to Ingress Controller. And Ingress Controller will then decide which ingress rule applies to that specific request. And the whole internal request forwarding will happen. So as I said, there are different ways to configure that and to set it up depending on which environment you are and also which approach you choose. But I think it's a very important concept to understand how the whole cluster setup works. So in my case, since I'm using Minikube to demonstrate all this on my laptop, the setup will be pretty easy. And even though this might not apply exactly to your cluster setting, still you will see in practice how all these things work. So the first thing is to install Ingress controller in Minikube. And the way to do that is by executing Minikube add-ons enable Ingress. So what this does is automatically configures or automatically starts the Kubernetes Nginx implementation of Ingress controller. So that's one of the many third-party implementations which you can also safely use in production environments, not just Minikube, but this is what Minikube actually offers you out of the box. And actually it's important to note here that on Minikube, Ingress on Mac and Windows is going to work slightly differently compared to a full production environment. It's going to use another feature called Minikube Tunnel to enable Ingress access to the resources, but we will see that in more detail in the demo. So for now, with this one command, we have added Ingress controller to our cluster. So once I have Ingress controller installed, now I can create an Ingress rule that the controller can evaluate. So let's actually head over to the command line where I'm going to create Ingress rule for Kubernetes dashboard component. So we're going to start by enabling the Minikube dashboard on our Minikube cluster by using this command here, Minikube dashboard. This is going to set up the dashboard in our environment and open up in a new browser window for us to access internally when it's ready. Let's close this and go back to the terminal. So in my Minikube cluster, I have Kubernetes dashboard, which is right now not accessible externally. So what I'm going to do is, since I already have internal service for Kubernetes dashboard and a pod, for that, I'm going to configure an Ingress rule for the dashboard, so I can access it from a browser using some domain name. So this shows me all the components that I have in Kubernetes dashboard. And since I already have internal service for Kubernetes dashboard and the pod that's running, I can now create an Ingress rule in order to access the Kubernetes dashboard using some host name. So let's go ahead and do that. So I'm going to create an Ingress for Kubernetes dashboard. So these are just metadata. The name is going to be dashboard Ingress, and the namespace is going to be in the same namespace as the service and pod. So in the specification, we are going to define the rules. So the first rule is the host name. I'm just going to call dashboard.com. And the HTTP forwarding to internal service path, let's leave it at all path. And this is the backend of the service. So service name will be what we saw here. So this is the service name. And service port is where the service listens. So this is actually 80 right here. And this will be it. That's the Ingress configuration for forwarding every request that is directed to dashboard.com to internal Kubernetes dashboard service. And we know it's internal because its type is cluster IP. So no external IP address. So obviously I just made up host name dashboard.com. It's not registered anywhere. And I also didn't configure anywhere which IP address this host name should resolve to. And this is something that you will always have to configure. So first of all, let's actually create that Ingress rule. So kubectl apply, and it's called dashboard ingress.yaml. See, Ingress was created. So if I do get ingress in the namespace, I should see my Ingress here. So this address here in a full Kubernetes environment would be the address that would map to the host dashboard.com. But as I mentioned previously, Minikube works a little bit differently, and actually for our demo, we're going to use the localhost address of 127.0.0.1 as a replacement here to complete the ingress steps instead of the address that appears here. So first we need to add this address to our etc hosts file and define this mapping. So I'm going to add the localhost address of 127.0.0.1 at the top here, which means it is going to be mapped to dashboard.com. This basically means that the request will come into my Minikube cluster, will be handed over to the Ingress controller, and the Ingress controller will then go and evaluate the rule that we defined and finally forward that request to the service. So this is almost all of the configuration that we need. I just need to run a Minikube tunnel to finish off the Ingress setup here. Remember, this is specific to Minikube. So if we were setting this up in a traditional Kubernetes environment, on a cloud platform, for example, we would just need to add the assigned IP address, the public IP address, to our hosts file instead of the local host without having to open a tunnel or whatever. But this is how it works in Minikube specifically. And as you can see here, it is starting the tunnel for the dashboard ingress. So now if I open the browser and enter dashboard.com, I will see my Kubernetes dashboard in the browser. Awesome. It's important to remember here that the Minikube tunnel is the process that is going to map this local address to the service for ingress. So if you stop the service and try dashboard.com again in your browser, without the tunnel, it's not going to work, even though it is defined in our hosts file. So I'm going to execute Minikube tunnel again and start up the dashboard once more. So Ingress also has something called a default backend. So if I do kubectl describe ingress, the name of the ingress and the namespace, I'll get this output. And here there's an attribute called default backend that maps to default HTTP backend port 80. So what this means is that whenever a request comes into the Kubernetes cluster that is not mapped to any backend, so there is no rule for mapping that request to a service, then this default backend is used to handle that request. So obviously, if you don't have this service created or defined in your cluster, Kubernetes will try to forward it to the service, it won't find it, and you would get some default error response. So for example, if I entered some path that I haven't configured, I just get page not found. So a good usage for that is to define custom error messages when a page isn't found, when a request comes in that you can't handle or the application can handle, so that the user still sees some meaningful error message or just a custom page where you can redirect them to your homepage or something like this. So all you have to do is create an internal service, so default backend and the port number, and also create a pod or application that sends that custom error message response. So till now, I have shown you what Ingress is and how you can use it. I've also shown you a demo of how to create an Ingress rule in Minikube, but we've used only a very basic Ingress YAML configuration. Just a simple forwarding to one internal service with one path. But you can do much more with Ingress configuration than just basic forwarding. And in the next section, we're going to go through more use cases of how you can define more fine granular routing for applications inside Kubernetes cluster. So the first thing is defining multiple paths of the same host. So consider following use case. Google has one domain but has many services that it offers. So for example, if you have a Google account, you can use its analytics, you can use its shopping, you have a calendar, you have a Gmail, etc. So all of these are separate applications that are accessible with the same domain. So Consider you have an application that does something similar. So you offer two separate applications that are part of the same ecosystem, but you still want to have them on separate URLs. So what you can do is that in rules, you can define the host, which is myapp.com. And in the path section, you can define multiple paths. So if a user wants to access your analytics application, then they have to enter myapp.com/analytics, and that will forward the request to internal analytics service and the pod. Or if they want to access the shopping application, then the URL for that would be myapp.com/shopping. So this way you can do forwarding with one ingress of the same host to multiple applications using multiple paths. Another use case is when instead of using URLs to make different applications accessible, some companies use subdomains. So instead of having myapp.com/analytics, they create a subdomain analytics.myapp.com. So if you have your application configured that way, your configuration will look like this. So instead of having one host, like in the previous example, and multiple paths here inside, now you have multiple hosts, where each host represents a subdomain. And inside you just have one path that, again, redirects the request to analytics service. Pretty straightforward. So now in the same request setting, you have analytics service and a pod behind it. Now the request will look like this, using the subdomain instead of path. And one final topic that I mentioned that we'll cover here is configuring TLS certificate. Till now, we've only seen Ingress configuration for HTTP requests, but it's super easy to configure HTTPS forwarding in Ingress. So the only thing that you need to do is define attribute called TLS above the rules section with host, which is the same host as right here, and the secret name, which is a reference of a secret that you have to create in a cluster that holds that TLS certificate. So the secret configuration would look like this. So the name is the reference right here, and the data or the actual contents contain TLS certificate and TLS key. You probably noticed the additional type attribute here. In Kubernetes, there is a specific type of a secret called TLS. So we'll have to use that type when you create a TLS secret. And there are three small notes to be made here. One is that the keys of this data have to be named exactly like that. The values are the actual file contents of the certificate or key contents and not the file path or location. So you have to put the whole content here base64 encoded. And the third one is that you have to create the secret in the same namespace as the Ingress component for it to be able to use that. Otherwise, you can't reference a secret from another namespace. And these 4 lines is all you need to configure mapping of an HTTPS request to that host to internal service.